All right, well, thanks everyone for joining. It's here the last session of the day. So I'm really excited to give this talk. I think for many of us, we've realized that event storming has really changed the way this community has worked, and that's really exciting. I think the fact that we're in 2018 really talking about collaborative practices for putting domain-driven design into practice, instead of just talking about the abstract concepts and what's an aggregate and what's an event. That's really exciting. And so the hope of this talk is that we can build on that a bit. So my name is Justin Holmes. I work at Red Hat's Open Innovation Labs, and I'm fortunate enough to spend most of my time doing DDD exploration. So very thankful for that. Since we started at the Innovation Lab, we've been using event storming extensively. Actually, this was the first lab we did in Ireland, and that was the first event storm I did. So that was early 2017. So since late 2016, been working with the approach, and we've loved it and been using it ever since. And what I want to do first is caution everyone that this is part of the Explore and Explore DDD. So I don't want anyone to walk away from this saying, hey, Justin Holmes said he's doing this thing in production and it's rock solid and it's totally figured out. That is not today's talk. Today's talk is about an idea that I think is interesting. I'm going to present to you the value hypothesis that I see with this idea, and then I'm going to invite you for feedback. So I'd really like to hear more about your thoughts and whether you see this working in your domain. Okay, so what's the thesis? So up on the board here, up over there, and up over on that wall, you've got an event storm. And so most folks should be kind of familiar with that. This event storm models out a ride-hailing service, so the process of requesting a ride and then a driver coming to pick you up. And all the event storms are the same. And I see what's really exciting about 2018 is there's a lot of teams that are doing this now. And there's a lot of groups that are getting together. They're having conversations between domain experts. They're bringing software folks into the room, maybe even their leaders, their managers, their executives. And they've got this great format for having a conversation. And at times, though, we struggle to keep going. What comes after this? And so what I'd like to present today is a thought around how we might do that. So the thesis I'm going to present today is that there are certain domains, there's certain teams that have a need to widely share their domain understanding. Not every project's like this, but there are some projects that are, and I'm going to give a few examples in a moment. But in those contexts, when we have teams working together, and they've got a wide array of people that might be geographically distributed, they might be distributed by role, and that wide circle of humans needs to share that domain model, that domain understanding, that there's a benefit that those sorts of teams might have from using a reactive BPM approach, a business process monitoring or modeling approach. We'll talk about what that means in a sec. That these teams would benefit from using reactive BPM to take an event storm and turn it into an executable specification. So an executable specification is a term that came out of the specification by example or behavior-driven development community. And it's got some really interesting properties on how it works in an agile delivery process and how it works in a documentation fashion. So that's the thesis. That's what we're going to focus on today. And I've sort of put up a picture here of what an event storm might look like. This is the same event storm you see up on the walls, and the BPM representation of it at runtime underneath. So we're going to take 5 steps today. These 5 steps, I hope, are going to make this idea clear. The first thing I want to do is clearly establish the value hypothesis. Because, again, this is an exploration phase, and so maybe there's some assumptions that are off here, and we need some help clarifying those. Once I've done that, I want to be a little bit more specific and clear about what I mean by reactive BPM, how that might be different than what we traditionally think about as BPM. I have a suspicion that this community is a little averse to tools like business rules and business process management, and so I'm hoping to dissuade you of some of that aversion. And then I want to take a small digression, given the context here, and provide a theoretical foundation. In particular, I think there's some really interesting conceptual similarities that led to the BPM community forming, and how that relates to principles and practices that we cherish here within the domain-driven design community. And I think it helps take a step back and understand those principles before we really look deeply at the practices themselves. Because if the practices don't put the principles into play, there's no point doing them. So we want to take a small digression and make sure that we understand the principles and the values first before we get really deep into how this works. Then we're going to take a look at working software, which demo gods willing will play nicely. And then potentially at the end here, we might do it in the hallways or might do it here. I want to ask for feedback and see what you think. Okay, so let's jump into the value hypothesis. To do this, I'm going to use a technique called impact mapping. Show of hands, who's used or heard of impact mapping? All right, so we got like 15 to 20% of the room. I'm going to use impact mapping to describe my value hypothesis here. And so when you work with impact mapping, the first thing you do is you establish why. You establish a goal. And so in my case, as I mentioned, I think the goal here is broadening the circle of shared understanding when that's an important requirement of the domain you're working in. Now, that's not going to be every domain. That's not going to be every team, and that's important. So any practice has a good context in which it works. This one is towards this broad circle type scenario. And so let's look at some examples, because the examples are clarifying. So a good example is, for any of these cases, and I'll talk about the role in a minute, it's any sort of organization that has a large business operations component. So I'm not talking about IT ops. I'm not talking about servers. I'm talking about people who work in call centers, people that are answering customer questions, maybe directly over the phone, over email. Anytime there's a large business operations group that's ultimately taking the results or the status of a piece of software and then communicating that to a customer. So some examples. Travel booking is a great example. We call in and we make changes to our travel all the time. And so there's a piece of software that a travel agent is using or a support agent is using, and they need to understand how that software is working so that you can understand what's going on. Insurance claims, credit applications, those are similar scenarios where there's a large group of business operations staff that's ultimately supporting you as a customer in the end. So that's the primary user driving this. Business operations teams, I think, can benefit quite a bit by increasing their use of domain language. We've found a lot of value in ubiquitous language within product development. It makes sense that when we ultimately have our user community to sort of understand that domain language, because they're not the end user. They have to communicate one step further out to the customer. And that's represented here. So we've got the goal, that's the why. We've got actors, that's the who can help us achieve the goal. And then impacts, which are changes in behavior. So I've denoted that with an up arrow or a down arrow. It's an easy way to think about how we change our behavior. There's a delta here. So the second behavior that I'm interested in changing is improving system-level understanding to make sure that business operations teams have a more systemic view of what's happening and how that leads from step A to step B to step C and what might go wrong between B and C. So the big picture, what does that look like? I'm also interested in how product owners fit into an iterative development process. And one thing that's interesting, I think, is incredibly exciting about the event storming community, and I think for what it's worth, the domain storytelling community, which I found out about today and I think is working towards similar goals, is it's a very inviting way for domain experts to come into the software delivery process. It doesn't start with reading a textbook, and textbooks are great, and they're the foundation of why we're here, but they're not always the most inviting. And so I think we've had great success with event storming and domain storytelling, bringing a broader group of people into the software delivery process. However, I've had some challenges with maintaining that enthusiasm, maintaining that confidence as time goes on. Because as we all know, software delivery is hard. It's great when we get sticky notes up there, and that's exciting. It feels like we've made great progress. And then you hit your first nasty defect. And then the database has an issue, and maybe your product owner isn't quite as convinced as they were in week 1 when you started with your event storm as they are in week 10, that we're really moving forward, that shared understanding is really there, and we've continued forward. So I'm interested in increasing that confidence and sustaining that confidence throughout a software delivery process. And what I'm going to argue here is that there's some scope that can help us achieve those behavioral changes that we're after, these impacts. And that's translating an event storm into a reactive business process model. And again, I'm going to clarify with specificity what I mean by reactive BPM next. So that's half of the equation. We also have software experts who are building products. And I'm interested in modifying their behavior a bit too, ultimately to get to this goal of widened shared understanding. I've labeled a group here founding developers, and if anyone's got a better name, I'm interested in hearing it. But I'm referring to folks who are starting projects, who are early phases, who are making key design decisions that folks who come after them are going to live with for a very long time. And I'm really interested in getting these founding developers to increase their use of event modeling and event logging. I think event logging is one of this incredibly cool software delivery practices that not a lot of teams do, but has so many downstream implications that it's amazing, particularly when we're thinking about business operations. Business operations teams need to know what happened when, because they're not the end user. They need to tell the customer, oh, we've moved you from seat A to seat B, and here's why. And they need to know the order in which those things happened. And so I really want to encourage these founding developers to increase their use of event modeling and event logging. And then after that, I'm interested in, again, not the group that starts, but the group that comes after, because there's an evolution to software delivery teams and software projects. So not everyone who's in the room on day one is going to be there month 3, month 6. So how do we make it easier for those people? And I'm not just talking about developers. In a lot of organizations, this means testers. It might be analysts of some sort. Your product owner might change. So how do we get those people up to speed? How do we reduce the time it takes for them to onboard? And finally, I'm particularly interested in remote team members. And this might be the nature of my customers, but I work in a lot of environments that have geo-distributed teams. So they might have a team in North America, they might have one somewhere in Asia, they might have someone somewhere in Europe. And I think we've all experienced that's a challenge. And yes, there's ways to help manage that with bounded context and context maps and kind of keeping teams in different parts. But at the end of the day, we have long-running business processes that are going to cross bounded context, and there's a need for system-level view across geo-distributed teams. This gets particularly hard, too, not just because of the time or the spatial difference, but time difference. There's not always a lot of time to have real-time conversation. So it's hard for a team in New York to do an event storm with a team in Chennai. It's just a physical challenge. So what I'm interested in here is how we can use an event storm to become an executable specification. A lot of the ways I view event storms right now are similar to if you're using a behavior-driven development approach and you're creating a set of scenarios to clarify your domain. A lot of teams get a lot of value out of that by never doing anything more than just specifying the scenarios. They get together, they talk through the scenarios, they write them down in English, they walk out of the room, and they never touch it again. There's a lot of value there. I think event storming for a lot of teams looks the same way. But in the behavior-driven development world, a lot of teams then take their scenarios, they turn them into unit tests or integration tests, and they run them in a CI system, and they turn out to be documentation that evolves with the system. And because they're tests, and because they're going through a CI system, they've got to be up to date. Otherwise, the build breaks. And so we have this wonderful artifact, this specification of how the system should work. And in the BDD world, you write this in human-readable language, these scenarios, and then you map that to a test case. So it's in English or whatever language you're working in. And there's a lot of value in this executable specification because I don't have the separate documentation task. I've built in self-documenting approach into the way I'm working. And so I'm wondering, is there a way for us to do that with event storming? And I'm going to argue here that an executable specification can be created from an event storm using a reactive BPM approach. Okay, so that takes us out of the first part and into the second part. So what's BPM? Traditional business process management world has two flavors. Flavor one is a big process engine that sits on top. It might live in a central ESB, and it's an orchestrator. It tells service one what to do, takes the result, does a translation between its domain language, then it tells service two what to do, so forth and so on. And so as your business process grows, the amount of translation overhead and orchestration overhead inside this central process engine grows. And that creates challenges, right? We're a community trained to look at this picture, this context map, and go, there's a lot of dependencies on that process engine, isn't there? That's the whole point of context mapping. It's supposed to visually tell us there might be an issue here. And a lot of organizations have experienced this because release 1 might only have 3 contexts, release 5 might have 20. How do we manage that problem? Most people don't. They fail. That's been the experience the industry's had. The other option is you build a big old monolith, and you put everything in the BPM engine, and nothing leaves, and all the data's there, and it might be great from a vendor's perspective, but if you're really trying to improve over time and iteratively release new valuable software, you're probably going to have an issue with this. I think reactive BPM looks different, and that's my hope. An important property of this is that our process engine has to be one way. It has to be conformist, to use context mapping language. So it's not going to try and understand the different languages. It's going to create a really simple language that just understands domain events and translates them to something called a signal. And a signal is basically the way that you event in a BPM language. So how do I pass in these signals or these events to the process engine? And that's all it's going to do. It's just going to map an event name to a map of data. So it doesn't matter what data comes, and it doesn't matter what name. I just need to know that a domain event occurred. That's it. And once I create that mapping, it works for every context that will ever live, because all domain events look the same. They've got a timestamp, I occurred on at this time. They might have an index. They've got a name, and then they've got a map of data. The other thing is, again, the nature of one way is it's read-only. So there's not going to be this software delivery effort inside the process engine to understand one language, translate it to another one, and then send something back. You're never going to see an event come back out. So it's kind of like a CQRS projection, if you're familiar with command query responsibility. It's just listening to data, and it's creating a process-oriented projection of the data. And I've just summed up those points again. So in a traditional world, you're dealing with orchestration. In a reactive BPM world, we're looking for a stream of domain events. In a traditional world, you're going to do a lot of heavy coding. There's no way around it, because you've got all this mapping to do. And everyone who's worked in software knows it's one thing to say the translation's easy and, oh, my graphical interface is going to be able to do it. And then you get into the details, and we all know it's a lot harder than that. Right? Domain translation is a challenge. And I work for a vendor. There's no way around it. There's going to be a lot of code if you're doing that translation. In a reactive world, we're just listening. So we're just read-only. We're not going to do the translation. And so you can get to a point where you just set up the initial infrastructure. So maybe you've decided to adopt Kafka, or you're going to use AMQP world. It doesn't really matter. Once you've decided how you're going to be sending these messages, maybe you use REST. It doesn't really matter. Once you've decided on the protocol and you've decided on the shape of a domain event, it's going to have a name, it's going to have a timestamp, then every context will look the same. You don't really need to code anymore. It's going to be distributed, and in a reactive world versus a more traditional centralized world. And in a traditional world, we need to be centralized because the same runtime has to have access to all the other processes, because he needs to call them and then orchestrate the downstream process. And in a traditional world, you're going to need to know a lot about BPMN2 because you're going to have to do all of this coding. You're going to have timeouts and all this other stuff. Because it's not a general purpose programming language. You need to learn the language of the process engine. In a reactive world, I just kind of want a flowchart, a sequence of events that we can talk about. All right, I'm going to take a small digression here. and I'll try and keep this one short, but I want to establish a theoretical foundation here, again, because I'm a little afraid of an aversion within our community to these kinds of tools. And so I want to take a step back, and I want folks to understand where these tools are coming from, and hopefully convince you that they're marching towards the same end. So to do that, I want to introduce this guy. Anybody in the room know who this is? Raise your hand. Who is this? Yeah, this is Williams Edward Deming. There was a great talk, I've got it linked in this, that Martin Fowler just did about the state of Agile in 2018. And in that talk, he argues that Frederick Taylor is probably someone you might not know, but did more harm in the 20th century than anyone else. And I'm going to argue that William Deming might be one of these guys you don't know that did more good and changed the daily life for the average person than perhaps anyone else in the 20th century. Deming comes from the statistical process control community, which was a place that was started by Walter Short in the early 1900s. And that community thought, if you can't describe what you're doing in a process, you don't really know what you're doing. Now, statistical process control was really, really, really important. It was a field largely driven by mathematicians and mechanical engineers who were interested in building better factories. How did we increase output? You got to remember sort of early 19th century industrial revolution and cars and manufacturing lines and assembly lines, and we're really changing the way we think about manufacturing, and we're doing it at large scales, and therefore starting to look about how we do manufacturing from a statistical perspective, understanding things like variation. That became really important. And this is where this community started. Somewhere around 1945, it became really, really important to rebuild a lot of the world. And what Deming did is he went to Japan. And he, in many ways, shared ideas that became the foundation of lean manufacturing. So when we think about the Toyota production system today, William Deming was responsible for sharing a lot of those ideas and bringing them to Japan. And obviously, the Japanese did incredible work with that, so he's not exclusively responsible by any means. But he was an ambassador that shared a lot of these ideas. Now, those ideas came back to a lot of the West in the form of total quality management, which led to things like Six Sigma that you might be more familiar with. And that's how most folks get familiar with these ideas. It is out of total quality management that a traditional BPM view is created. This idea that we want to understand how our organization operates, we want to create an automated view of it, we want to inspect, and we want to adapt, and we want to get better. This is the Short cycle. Plan, do, I'll forget it on stage. Plan, do, check, study, act. Right, there we go. That's the Short cycle, and then, yeah, thank you. So anyway, the idea in the 80s and 90s was, well, we can't really do that in our big distributed world without having some software to help us do that. So wouldn't it be great if we had some sort of software that tracked our processes, and then we could do some iterative improvement with that? Seems like a good goal. Now, without getting too much further into that, there's a paper that Deming wrote that established the system of profound knowledge. And the system of profound knowledge it focused in 4 areas. It was articulated in 14 points, so you might hear Deming's 14 points, but there was sort of 4 principles of it. And what I've done is I've taken the 4 principles that Eric used in last year's keynote here as the principles of domain-driven design, reordered these, and I've lined them up. So the top one in the system of profound knowledge was the focus or of appreciation of a system, the understanding of the big picture, so that when we optimize in part of the system, we don't do local optimization that actually hurts the whole. This was really important. And we talk about this in DDD all the time. We create context maps, we try to distill the most important part of the business, focus in on the core domain, but we don't want to lose sight of all the other parts of the business. Seems to me to be a common value. I want to do some systems thinking here. Now, there was different objectives behind those principles and those statements. These people were operating in different contexts. Deming was more interested in sort of traditional management consulting and helping executives understand how to think about their organization. We have a little bit different focus with building software products. But from both sides, we're placing a value on systems thinking and understanding the big picture. Once we've got that in place, and this is really where I think Deming had a lot of that positive impact on the day-to-day life of the average worker. Deming talked about the knowledge of psychology, and in particular, incentives, what makes people work well. Deming's one of the people who really established this idea of potential for self-organizing teams, that management by numbers, management by objective, maybe not the best approach. Maybe we need to let those who are closer to the work figure out what they're doing. And we love that idea in our community, right? We love self-organizing teams, cross-functional teams brought together who can figure out how to solve their business problems the best. That idea was not always the case. Taylorism was very much a hierarchical structure where you had someone at the top figure out what work needs to be done and then distribute it to the workers to do. So Deming really helped change that, and I think our community shares an appreciation for that value of how humans think about incentives and how they do work. The third point from the system of profound knowledge is the theory of knowledge, and in particular, the notion of operational context. So if you'll recall, in the early part of this, I talked about statistical process control, and that's sort of the origin of these guys. Well, in statistics, there's a lot of numbers, and so I think anyone has probably seen a statistic put forward on a slide deck and say, well, that's out of context. Doesn't make any sense. You can't say this about that. And in this body of work, Deming talks about the importance of operational context when you were looking at processes. Who would have thunk a community that cares about context? And the fact that when I say a word or I give you a number, it's got context. It has to live around other things. So for a community that really cares about bounded context, there's a lot of similarity there. Now, the last ones are where we kind of diverge. The system of profound knowledge is interested in variation, particularly what that means from a manufacturing perspective. We're more interested in building software models. So this is our context showing the principles are different. But I think there's a lot of similarity in the first three. And because of that, I think the practices that come out of these principles are worth exploring. Maybe they always haven't given us the right results, but I'm going back to those practices and those tools because I think the principles are sound. So maybe if we change the practices about a bit, we'll get a little bit closer. So that's the hope. So thanks for listening there. All right, so enough of me pandering on. Let's take a look at some hopefully working software. Before I do that, actually, I need to turn your attention to the sticky notes. So I'm going to take a look over here. I'm going to try not to cover it too much here because we're going to try and make this work with the camera. I've got on stage here as well as on the window over there and the window over there. I've got an example of what would come out of an event storm. And if you recall earlier, I was discussing that we're working in a ride-hailing situation. So I want to create a company called Cabot. We're going to compete with the Ubers and Lyfts of the world. And I want to describe here the ride-hailing process. So I started off kind of in an event storm with my team, and this might be the output of that event storm. So we had a conversation about really where to focus first. And so one of the things that came up is, well, there's a whole process around drivers signing up and riders signing up. Well, those are important. They're identified here in the purple. That's kind of the notation to indicate a process. They're not our focus. So they're up on the screen, but we're not going to focus on them here. Same thing with selecting a destination and the type of ride that I want. It's important. It starts this process off, but it's not the focus. So we really want to focus in on the actual process, which is going to begin here when a passenger requests a ride. And so that's the notation. We've got the yellow sticky here that indicates a passenger. The blue sticky is indicating a command, so a decision that the passenger has made. They want to request the ride. They've hit the big request ride button, and they're hoping that the system is going to request a ride on their behalf. So we make a event once the system's received that. Ride's been requested by this passenger at this time. And the yellow sticky, or the green sticky here is just indicating that we've got a screen to help us do that. I haven't sketched out the screen, but this is where one would go. Now, once the ride's been requested, that ride's got to be dispatched. And this, I think I'm supposed to say purple, right? Purple for policy here, is an important part of the business. Matching rides with drivers, that's hard. There could be a lot of drivers. They might not be going all in the same direction. Some might have different statuses. Maybe some got more rides than others. So there's a lot of work here. Now, we're not going to represent it more than that, other than to say this is an important business policy. We need to look at it more deeply. Once the ride has been dispatched, we've got to send that dispatch to a driver. And the driver's going to have an option to make a decision here. So the driver can either accept or reject the dispatch. And they're going to have a screen to do that. I've just duplicated that. So these are sort of the two outcomes that the driver could make from this screen here. They'll either accept or reject the dispatch. Now, in the case where they reject the dispatch, the process is just going to come back and redo the dispatch policy, because now I've rejected it, so we need to find another driver so that our passenger can ultimately get a ride. In the event that well, let's go back. So we'll do that. Our system will send the dispatch again. We'll get a new driver, and this time the driver is going to accept the dispatch, and now I can begin the ride. He's going to navigate, hopefully, to go pick me up. Now, navigation's complex, and I'm not going to focus on it here. But again, I've indicated that it's here, so it's sitting inside this process, but we're going to skip over the details of that sub-process for now. And the last two steps, hopefully there's no issue with navigation. The driver heads towards my passenger. They pick up the passenger, and then ultimately they'll go to where they need to go, and then they'll drop off the passenger. Now, once I've dropped off the passenger, that's going to start the payment process. Again, payment process is important. It's not the focus of what we're going to do here. So you can imagine if you were working on a project to deliver this, this might be the kind of artifact that you finish with. And this is great. Now, usually event storms are a lot more messy than this. So this one's nice and clean and pretty and demo ready. But you might leave the room, hopefully with the kind of shared understanding that I was hopefully able to impart about what we're able to do. So the rest of this conversation, we've got another 10 minutes here or so. The rest of this conversation is going to take a look at how we can turn this into a piece of software. And I'm going to hope the network is going to help me here, and the demo gods are going to be kind. I've got some software running in the cloud right now, and it's actually running in North Carolina, so hopefully the hurricane doesn't get in the way here. And what I've done is I've gone and I've drawn out the same process inside a process modeling tool. I'm using JBPM here, which is a community process modeling tool, but nothing I'm going to show here today is specific, like technology specific. Like any community that builds software like this is going to have basically all these concepts: how to model a workflow, how to execute it, how to look at it at runtime. So there's nothing unique about JBPM here. So you can see I've got the same steps, right? We've got to start. The ride's been requested. I dispatch the ride. Driver's going to figure out what to do. They might accept it. They might reject it. Now, in the event of a rejection, I got to come back. Now, you'll notice there's no policy here, and that's one of the areas for further exploration I want to talk about at the end. But we'll go back through. We've got the dispatch sent. The driver will decide to accept it. I've got the navigation process here, and I've just kind of made him a pass-through. So I'm not going to focus in. He's represented, but it's just going to print out hello world. And then the passenger is picked up and the passenger is dropped off. So because I have disconnected here, let's make sure he's back. Okay, so let's take a look at how this guy's implemented. So I've created a reusable sub-process. It's a very common approach in this world. And all that sub-process does, I'm not going to pull it up here, but all that process does is it takes a piece of data, which I'm going to show you in a moment, and then it sets basically the signal that is being waited for. So that signal is going to be our mapping to a domain event. Once it's got that signal set, the process will sit and wait on it. So it'll wait until it receives the signal. Once it receives the signal, it'll take all the data inside the event, and it'll map it out into the process, just as a hash map. So it'll go through the key set, take all the data, put it on the process. Nothing more than that. And you can see every one of the steps here has the same sub-process. So they're all reusing the exact same sub-process. The only difference between them is this assignment here. So that might be a bit challenging to see, so I'm going to make that bigger. This assignment is just going to take a piece of data called a name, and it's going to set it as a variable in the sub-process. And what I've done here is I've just set the name of the event I'm waiting for. So in this case, the ride requested event is what I'm listening for. And that's going to tell the sub-process, hey, sit on a signal and wait until the ride requested event comes. That's all it's going to do. And if I take a look at each one of these, the dispatch one here, you can see that it's got the same thing. So it's got dispatch accepted here. And they're all going to do the exact same thing. The only difference here is that because there's a fork in the road, I've represented one of the commands, one of the decisions as a fork in the road here, and that's why the human task is there. It gives us a chance to pass in the data that will decide to go left or right. Now, there's a small piece of configuration there, and I'll talk about that later as a place for further investigation. So what I've done is I have built this process model, and all right. And it is, hopefully, oh gosh, well, there's the demo gods. Let's make sure that we're up. Okay, well, it should show me that it's deployed. Oh, here we go. Sorry, just network piece. Well, this piece is here, and this is actually deployed out. So it's running this version 1028. These other guys are artifacts that are just sitting around because I've been testing this today, so don't worry too much about them. So again, version 1028, this is just the system telling me it's deployed out and it's ready to be running. And then what I'm going to do here is just quickly show you the instances that are active. So right now, there's nothing active in the system. And if I actually do that, you can see all the processes that have run before. So let me quickly now turn to how I exercise this. So writing this code, the thing that was actually most interesting to me, I'll comment this first. If you recall back to the impacts that I was after, one of the things I wanted developers to do is to model events and start logging them from the beginning. To do that, you got to create some classes that have your events in them. And a happy side effect of doing this work was in my app, I had to go and model the events because I had to send them over the wire. So the first thing that I did to write the code here was model my domain events. And so you can see I've just got a JUnit test class here, and this JUnit test class is going to create events. And then I've got a client-side adapter here that's using the JBPM REST API. In the future, I'd like to actually push that the domain translation into a messaging system and push it into the server because there is a stateful mapping between each aggregate and its specific process ID. Haven't finished that code yet, so further exploration there. So right now that mapping is being done server or client side, and it's what this adapter is doing. So if we look at each of these lines, I create a domain event, I publish the domain event, and that's that. So happy side effect. I had to go in and do things like just define a ride requested and what it looks like and what pieces of data there. And that was surprisingly clarifying because it's one thing at a whiteboard to say I've got a ride requested, but what data's on it? And what other aggregates does it need to map to? And how might that work? And so actually just starting by writing the classes out and thinking about what those classes were, even before writing the aggregate classes, was instructive. I found that really interesting. It kind of gave me clarity that, hey, I actually need a dispatch aggregate. The dispatch is going to be separate than a ride because they're going to kind of work at different times. So once that's there, what I'm going to do here is I'm just going to run part of the process so you can see what this looks like. So this is going to run. And what I should be able to do now is hit refresh. And I've got two processes running. So the one that's blank is that sub-process, and the one here that says ride is the ride process. And so what's nice about this, I'll make it full screen, is we can now see, and let's scroll down here, it's kind of big. I'm going to zoom out a little bit. So what we can now see is the same diagram that I showed you before running. And we can see that a ride was requested like you saw in the JUnit. Ride was requested, the dispatch was sent, and then the driver decided to accept it. Now, all of the grayed out boxes are the parts of the process that have been executed. The one that's highlighted here in red is the currently running one. So this is waiting for a domain event to come in. It's sitting here waiting on the process. Anything that's in white hasn't been run. So it's an unexecuted path within the process. Now, one of the coolest parts about this is all of these process engines have a way for you to see the running variables. So imagine I'm at a call center right now, and someone calls in, and they want to know what's going on with their credit application or what's going on with the booking. It'd be nice to see where I am in the process and also what data is relevant to me. And so these are just the values that were on my domain event. And again, there's no translation here other than just hash map. So just push the map over. So you can see the destination I was interested in was the location of the conference. And this was my pickup location, which is at Union Station here in Denver. And you can see the ride ID. And what you can also see is just a history of the events that have happened and the time sequence and when they happened. So first a ride was requested, then a dispatch was sent, and then a dispatch was accepted. Quite useful if I got to communicate that maybe to a customer over the phone or something like that. So that's the first test case, just to kind of show you that running. Now, if you remember, I said one of the areas for further enhancement was to push the state of the mapping onto the server. Well, since I just ran the test case, I've lost the state. So I'm going to just run the same test all the way through. And this time, we're going to pick up the passenger, and we're going to drop off the passenger. And I'm just going to push this over. And that test case is finished. So we should only see 2 active processes because the process finished. So what I'm going to do this time is just pull up the same process model. It's a new instance here. And we can see now that I've run through the whole process this time because everything's gone through. In the interest of time, I won't show you the variables, but what I will show you is the SAD path. So let's take this scenario here where I request a ride, dispatch is sent, it's rejected, and then I want to send the dispatch another dispatch. A new driver accepts the dispatch, pick up the passenger, and then I drop off the passenger. So I'm going to run that, and we'll take a look and see what it looks like in the runtime. So I'll pop this over, and I'll just update here. And you can see more steps have happened this time. And I'll take a look at the diagram. And you can see now all of the steps are highlighted. And this makes sense because I've gone through all of the steps at one point or time. Now that might be visually confusing. I might want to know the order of those events. And so if you recall, again, I can come back to the process variables. And this time I can see again the history of the events. So I can start at the end or the beginning. Ride requested, dispatch sent, dispatch rejected, dispatch sent, was accepted. And then passenger picked up, passenger dropped off. Last thing I'll show you here, and then I'll wrap up, is business data actually changed throughout that, right? I got a new driver ID. I might want to know which driver's IDs I had. So what I've done, because I've gotten the same event, I've updated that variable over time. So I can now see the first driver who dropped me off was UID AAD, and then the second one was 044. Now, of course, this is a demo, and there's simple examples here, and the data itself isn't interesting. But hopefully the foundations that are at least presented here, you can see how those things might be useful in your projects. So that covers the working software. The last thing I want to do, and I'll end here, is I just want to mention kind of a highlight of areas for further exploration. So I think visualizing policies could be really interesting. Not sure how to map that to BPMN, so I'm curious what this community would have to say about that. I'm not sure if it's valuable to clearly delineate bounded contexts. And if so, do you do that in work or swim lanes? Do you do that with colors? I'm not sure. Curious for your feedback. Right now, this business process is mapped to a single aggregate. So oftentimes we talk about aggregates as a state machine. This is essentially the state machine for a ride. But what if we needed to span a process that was many aggregates? Is that a good idea? Events that could happen at any time. So I didn't model anything that comes out of band here, like canceling a ride. There's ways to do that in BPMN. I just haven't represented them here. And then some technical stuff. So finishing the Kafka integration, and then also looking at things like change data capture, so that delivery teams don't actually have to see the event logging mechanism. They just have to write their event logs to a data store, and then we can use things like change data capture to actually stream out those events, so it's more seamless for delivery teams. So that's the focus of the talk. I thank you for your attention, and I'm really interested to hear your feedback in the hallway.